Unit 3, Circles and Volume. This is Lesson 3, Segment Lengths and Circles. And what we have here in a circle, we have two congruent chords. We have chord AB and chord DC that are congruent here. And I'm going to highlight them. So AB is congruent to DC. If they are congruent, then they are the same distance from the center. In other words, we're referring to this distance here from the center to the chord from F to G, and then from the center F to E to that chord. Those two distances will be the same. So we're going to write what those congruent parts are, and those segments are FG and FE. Okay, then if you have in a circle, if you have a radius or a diameter that is perpendicular, in this case we've got a diameter that is perpendicular to a chord, then it's going to bisect that chord. In other words, when it bisects that chord, it creates congruent parts BA and BD. So we have BA is going to be congruent to DA. So if I were to ask you what is the length of BA, since you know that it is going to be equal to DA, and DA is 5, then you therefore know that BA is also going to be 5. Alright, then on that same notion, if you have a diameter that is perpendicular, or radius that is perpendicular to a chord, so here we have, whether it's the radius or diameter, is perpendicular to a chord, so we have diameter BD or radius BA perpendicular to chord CE, then it is also going to create, it's going to bisect the arc intercepted by the chord. So that means that this arc, the degrees of that arc and the degree of this arc are going to be the same. So we have the measure of arc BC is going to be equal to the measure of arc BE, and let's see if I can clean that up some. You have, alright, so that's BE, that arc. Now, the measure of arc BC here is represented as 4x. And then you have 80 minus x for the other arc. So if you were to solve this, add x to both sides, and you have 5x equals 80. Then divide by 5, and you have x would be equal to 16 in this case. And then if you wanted to find the actual measure of that arc BC, you'd plug the 16 back in to solve for the actual measure of those two arcs. And then you have a case where if you have two tangents to a circle, we have tangent QR here, and we have tangent QS. And in this case, the tangent segments drawn from the same point are congruent. So, QR and QS are tangent to circle C with a common external point Q. Alright, you have your common external point Q here. So if you have a line drawn from that Q to the tangent CR, tangent point R, and the point Q to the point of tangent CS, those two tangent lines will be congruent. So you can solve this simply by setting them equal to one another. If you have QR is congruent to QS, then you know that 32 would be equal to 3x plus 5. Subtract 5, you get 27 equals 3x. Divide by 3, and x is 9. And then if you needed to find the actual measure of that tangent line, you would go back and plug the 9 in to find QS and QR. Alright, I'm going to stop here. This will be part 1 of the lesson 3, and then I will pick back on part 2 on the next video.